After having reviewed our series and parallel rules, let's design our first real circuit, the voltage divider. Any circuit's going to have two things, an input voltage and an output voltage. In this case, we're going to have a circuit with two resistors, R1 and R2, and the junction between the resistors is our output voltage. The purpose of a voltage divider is thus to make the output voltage less than the input voltage. Sometimes we have a device where we can specify, I would like 1 volt, and maybe in software we can just have a little slider bar and it makes 1 volt for us. In our particular case though, the Nscope only provides a constant 5 volts. So if we wanted to make a constant 1 volt out, so maybe this is 5 volts, and we're trying to make 1 volt, what circuit can we build to reduce the 5 volt into 1 volt? Here's a couple ways to think about it. 1 volt is a lot closer to ground than 5 volts is. So we probably want a kind of like a bigger resistor here and a smaller resistor here, so that this resistor eats up like 4 volts, and then we have the remaining 1 volt across R2. So this relies on the fact that any input voltage is always relative to ground, and any output voltage is relative to ground. So when we say the voltage at this point is relative to ground, the V out relative to ground is the same thing as the voltage across R2. So we must have 1 volt plus 4 volts equals 5 volts. So that probably says something like, oh, well, this should be a 4-to-1 ratio of resistors. So I could put a 4 ohm resistor here and a 1 ohm resistor here. That should feel a little funny though, because we know that if we have 1 ohm with 1 volt across it, there must be 1 amp going through here. So there's 1 amp going through the 4 ohm, and 1 amp going through the 1 ohm. That's a lot of current. We know the Nscope turns off at 100 milliamps. So we probably want to be dealing in the milliamps of current. That feels right. So how do we get milliamps worth of current? Well, we use thousands of ohms. So we use 4K and 1K. And if we were going to build this and we could use our multimeter, we could put our black probe on ground and the red probe across R2, and we would see 1 volt. So why exactly does this happen? Well, we could think about these two resistors as being in series, and two resistors in series is the same thing as one resistor whose value is the sum of both. So this is a 1 plus 4K resistor. So this is a 5K resistor from 5 volts to ground. Okay, if we have 5 volts and 5K, I equals 5 volts over 5K equals 1 milliamp. So there's 1 milliamp going through this 5K resistor. That's the same thing as saying this I and this I are both 1 milliamp. So if we have 1 milliamp going through a 1K resistor, there must be 1 volt across it. So this is a lab exercise. I'm not going to derive everything for you, but we should be able to find an equation for V out in terms of V in times some stuff with R1 and R2 type stuff. Just remember that it usually involves taking your resistors, converting to a single resistor, finding the current, and coming back. Now the assumption that we're making is that all of the current that comes out of 5 volts through R1 must go through R2 to get to ground. Typically though, we'd like to take V out, the 1 volt, and use it for something. Using it means I want probably some current to go feed the next part of the circuit. Well, where does that current come from? It must be stolen from the source current, meaning that there's less current going to ground. If there's less current going to ground, that voltage must dip. This is going to be a theme we'll see in the remainder of the labs, that adding things to our output could affect the voltage that we expected.